First of all, welcome back to today's class. Today is day number 11 into the semester week number 6. This is MATH113, section 7, applications of mathematics in today's world. First of all, I have to appreciate your efforts to come back here in between holidays, okay? So it's very important that you come back here, enjoy the class, it's very good. Now I would like to share with you the result of the midterm core survey you did as of last week. So let's go through the result and then I try to provide some feedback on my own. First of all, as far as the pace of the course is concerned, I got 9 students in this class who believe we're going too fast. And I got 12 students in this class who believe we're doing good. And I got 2 students in this class who believe we're going too slow. So that means from the result of these questions, I understand that at least 3 different batches of students will have different interpretations of the pace of this class. And it's very important that I have to make it clear that it's my purpose is to give each one of you in this class an environment to learn which could be done at your own pace, How can I do that? Well, if I go it the traditional way, write something on the whiteboard and ask you to follow me step by step. This is a magical pace in the traditional classroom. But you just have one song. Okay, that means you can only experience that one song. So in this particular class, I did it the other way. That means I got everything prepared before I come to the class. I put everything I prepared on the website. And I would like you to make sure you go into the website and do your study step by step there as many times as you can. So you will never have a chance to miss something. That means you can control the pace of learning at your own. That is done through technology. So in principle, I should expect differences between the 3 of this to be narrow, but I still have to be very careful when I discover at least 9 of you believe we're going too fast. That means you have to make sure that I understand the difficulty. Now, as we read the response of the survey, I got some hints, so let us go through it first. Okay, the second thing is, how much do you understand about the course presentations? The presentation of the course includes my explanations in class, giving you just enough introductions, the material presented and through the website, and the importance of pointing you where we are. So let's say at least I got 1 student who understands 0%. I have to invite the student to come talk with me. So what can we do about this? And 5 students say 25%. So I believe 25% of what we've gone through in the first 5 weeks, okay? So, and then 10 students say 50%, 5 students say 75%, I got 2 students who say 100%. So again, the course presentations has to be done in such a way that in the traditional classroom, the teacher will understand how much you understand by looking into the homework you did, by checking you on the quizzes you did, and by overlooking the test result. But in this classroom, we say, no, we're not going to do a lot of things like this, but today we're going to look at the homework, okay? So it's very hard to just draw a line here. But again, since it's not just one song in class, you have all the resources that are prepared on the website. So if you happen not to be able to understand something presented in class, you should ask questions. Not face-to-face in class, okay. You can ask me in my office during office hour. You can ask me through Dr. West's Q&A hotline. So this is very important. Remember, I often ask you, what are some of the things in class not clear enough for you to understand at the beginning of each class? And then the social discussion forum there, normally, I will not receive any response, all right? So if you need help, make sure you should let me know what your needs are, okay? If you happen to know nothing about this, make sure you come to me. It's safe. I'm not going to kill you, all right? All right, so how much do you understand about the course material? presentations, almost something similar. If you go through the course website, you understand we have laid out a lot of things for you, particularly before class activity, to know that. Before class activity, you study those things, and you know that you have to get yourself prepared. And then during class, what we're going to talk about after class, we have everything, notes, the videos, the working problems. So all of these are expected that you have to go through them in order to understand those materials. If you don't go through them, you just rely on, say, classroom presentation, that is in a whole way very difficult for students to understand within just minutes of teachers talking on the whiteboard. So we solve this problem by using technologies to make sure those material explanations are often 24/7. So in case even those materials are so accessible, you still cannot understand them, ask questions. So let's take a look at 9, 25%, 6, 50%, 6, 70%, and 200%. Now, I must tell you that I did not design those questions. These question and question. It was done by the faculty for us. And personally speaking, if I were to set this question, I would not ask something like this. It's very difficult to tell. Why is 25% not 24? It's always approximate. But at least we got some sense of the pockets of students in your class and how do they feel, all right? So this is question number 3. And then, here we go. You have any suggestion in group teaching, please feel free to let me know. Now, from the reading of the first sentence, I know that I still have a long way to go to transition you from being a taught-to-learn student to a learn-to-learn student. You see that the purpose of this course is from the very beginning of the semester is we want you to transition from what you used to be in high school, where everything you need to learn must be taught to you by a teacher, to someone who could become your own teacher. And how can you do that? As teacher, in this class, I will consider myself a facilitator. I prepare an environment for you. I set all the units for you. And I make sure that if you study that before class and do that during class and after class, you should be able to understand this. Now, one of the difficulties of being a student is to so much cling on the old way of getting things done. I must see the teacher write on the whiteboard so that I would say he is teaching. And in the contemporary world, we can actually learn anything from the internet, okay? And we have courses like Coursera, MIT course where we're using. Everyone in the world with an access to computer can actually learn from this because of what? Because they are well-structured units of instructions, okay? And we have to get used to learning something online at our own pace. Now, the advantage of doing this in class in a university like this is you have me as your resource. So at any time, if you have studied something but you discover a problem, make sure you come to my office and ask a question. With the document security online 24/7. I promise you, I will answer your question within hours of your living your question. And actually, I've been doing that. So please do not have any bad feelings when I invite you to watch something, to learn something. The reason is very simple. The other day I have actually given you this, okay? This is a very interesting article. And it tells you a lot because of Salman Khan's enthusiasm to help kids to learn in the United States. He's a world-famous figure today, and his resources, the Khan's Academy, is used by almost many of the kids around the world to learn what is needed. And his style of teaching is so much wonderful that you can always follow it. It's not long, it's up to the point, and all the important structure for you to learn it. If you look at the UMUDA website, we use its video. And the most important thing is, it's called a personalized learning method. We all expect a wonderful teacher can take care of individual students' needs, but we really cannot guarantee if this is your own pace of learning. So we produce learning material in such a way that you can watch them, read them, study different problems. And sometimes, if you look at our website, besides using Khan's Academy's stuff, I've also used different wonderful teachers' tutorial here. And when you look at my before class activity, then I invite you to do it. It's so easy for you to understand something. And most importantly, remember at the beginning of the semester, I invite you to watch a video called Stop Teaching Calculating, Start Learning Math. Okay? If you look at the old days of your learning, when the teacher writes on the whiteboard, he is telling you how to do step-by-step calculations instead of telling you the math behind it. So I seldom do that because you can learn this from the working example. Rather, when I manage a class, during each class time, I try to make sure that each individual concept, you need to be learning all this. And so I stop the video and say, do you remember this? Do you remember that? Because you must go through this process. It's so much comfortable when you watch the teacher write on the whiteboard and copy the notes into your notebook. But that is a very inefficient way to learn something. When you have the video, make sure you understand this is the technique I need to learn, this is the concept I need to acquire so that I can move through your project. You have to do a project to work before the end of the semester. The project must be based on your understanding of the concept, okay? Not just the individual calculation step, because this course is for applications of mathematics in today's world. And calculus happens to be one carrier of that, okay? So read this article is already in your week number 5's topic online discussion forum. And make sure you watch this video too. Salman Khan is trying to tell you that we really want to get to help individual students with their own pace of learning. But you have to go through the process. Don't say that, my English is bad, I can understand. Watch them again and again, all right? This is one way for you to learn. If you always say that my English is no good, please tell me in Chinese or show me the step. Come to my office, I can help you. But in the big class, I have to take care of everybody's need, all right? So that it's quite different. All right, so let's take a look at the questionnaire again. More example in the lessons. We're getting into those examples studying 2 weeks ago, okay? It's very important you practice examples in class and then we go to a new concept, so don't worry much about it. Teach us some difficult sums in your own words. I have difficult understanding this. You mean the sums, summations, or what exactly is this? Maybe it's the methods, all right? So this is something I need to understand more. In my opinion, it's too difficult for a student who was from the Chinese high school. They may be confused with the math. Okay, I think that's where I can write on the whiteboard, not just play the video for it. It's quite difficult for us to understand the calculus. Okay, I would highly suggest that if you have this need, you need to come to my office, all right? We can talk about this. It's very difficult to learn English if you were from a Chinese school. I tell you my personal experience. I stopped learning English at the age of 13, okay? Before the age of 13, I'm totally from a Chinese school. So I stopped learning English at the age of 13 when I transferred from the Chinese sections of my high school to the English sections. And I remember that I have to go to evening class 1 hour per day to pick up what we call the fundamental of English. And it took me 1.5 years before the teachers tells me you can go on your own. You don't need to spend extra time because you have to go through a transition period. And the transition period has to be done in a way that you find it useful to you. Now I have to tell you, this is not an English class. I cannot teach you English here, but if you look at my course environment, I did provide some very important English tips at the very beginning. You can learn it from the home. Okay? So this is, I can only help you with that if you need the help with English. Okay? At the very beginning, you see that we have free online English dictionary with Chinese, and free English learning points for English level here. I promise you, if you have ever visited this link, you understand that they teach you English from kindergarten to university level. And if you are conscientious to learn your own English, it just take you half a year. And you will be set, okay? You will be set. This is how I help students learn English. Let's go through this particular website. You have Start plus English Elementary, Pre-Intermediate, you have Upper Intermediate, you learn grammar, you learn conversations, you learn compositions, you learn comprehensions. Everything is free of charge, okay? That is technology. I will tell you that it's equivalent to my going to class when I was 13, 1 hour per day. If you can spend 1 hour per day here, I promise you half a year your English will be highly improved. Okay? At least you can read, write, all right? So you need to do something, okay? You cannot always rely on someone adjusting to your learning style, particularly in this class. We cannot speak in Cantonese or Mandarin. This is officially the rules of the university. If it is not a Chinese class, if we ever speak in Cantonese or Mandarin in class, the school will fire me. Okay? Official language is English speaking. The school has a lot of regulations. But if you come to my office, I can talk with you, explain to you in Chinese or Mandarin. Okay? But in class, it's very hard. No, we cannot do that. There's some regulations. Okay? And then, let's say, writing on the whiteboard. I will not do it all the time, but I can do it some of the time because I prepare all the things using the videos. Okay? They didn't what I expect to do, except for some of the time they wanted me to show you the step. I did it through the Microsoft Word, just like today. After you have submitted your work, okay, you can see that the sample solutions of your homework is already given to you after the deadline, and you can see that when I do something like this, I did it through Microsoft Word, all right? So check on this. And beside those questions, as I said, in each class now we will spend at least 30 minutes time doing examples. So I think you can help me to help you, okay? You don't just expect teachers to go the directions of your high school, because you're now in college and it's quite different. Calculus happens to be one topic we go through. After that, applying math concept, not applying calculation step, okay? That is very important. I'm helping you to go through the transitions, okay? So let's go back to here. Yes, I think we can have more group discussion in class. Surely, that's the purpose of you forming a team and sitting on the round table. That's what we're going through now. And principally speaking, you've gone through the peer-based discussions. And I've seen a lot of the discussions online between the two of you and your peer. I'll just show you some of this. You need to follow this pattern to discuss with your peer member. So, again, if your major is Chinese, don't worry much about it. English is a language, it's not hard to learn. You can always ask me questions during the office hour. Send me your question using Dr. Vet's Q&A hotline, which is 24/7. Okay? Video teaching is not suitable for me. I think I will highly suggest it. Ask yourself why. The video, you can use YouTube to adjust the slow speed so that you can always listen to them in slow motions. Okay? If it's a video for 5 minutes, when you listen in slow motion, maybe you watch it for 10 minutes. So you can always adjust the speed, all right? So when you study something with a video, you have to ask yourself the question, why I'm watching this video? For what purpose? Okay? Because everything you learned could be learned without teachers today. Because everything is already there. Even professors learn a lot of things from other universities free of charge course. We call Coursera, we call Courseware, and I invite you to take a look at the first week. Remember that? From day one, I say, well, you really do not need a teacher. As I said, from week number 1, you see that I invite you. You can always learn calculus from this source, from this source, from this source, from this source. A lot of sources you can learn calculus. A lot of people can teach you. Okay? And if you really want a Chinese teacher, you go to Peking University side, you go to Taiwan University side, and learn calculus using Chinese. But in this class, we have to do it in English. Okay? So make sure you understand the challenge you need to accept and the support I can provide you as a professor. Okay? Very good. You do not need to too humble in the sense that English is not your not good enough. As I said, it's just a tool. English is a tool, medium for us to use to learn from the world, to communicate with the world. It takes a while for you to adjust to it. And college here is an excellent time for you to pick up English. For example, a lot of my friends from Beijing, they study in Chinese, but when they go to the United States and Canada, it does not take long for them to adjust to it. And many good professors, the English is not very good when you listen to the conversation, but their critical thinking is excellent. So your job here is to make sure you just use English enough for your own purposes. Okay? So don't be too shy on your. It's not a big deal. English is not a big deal. Okay? Bring more discussion and meaningful tasks in the class instead of bring video. Well, you want. This student want to do it. They want to do tests instead of learning from the video. Okay, I promise I'll give you some more exercise. All right? Discussion is very important. All right? So then everything is okay, explain in the right one, not just watching the video. Now, remember, watching the video is one way to get to the content. All right? So don't get offense when I invite you to watch the video, because the teacher here, I'm a facilitator of navigating you through the path. And so a lot of the things I would offload. Oh, have you heard about the flipping classroom concept, which is written by the Chinese article there? A lot of the school in Hong Kong now, they do it this way. You can always learn what I expect you to learn at home. When you come to the class, you do exercise. But make sure you study the video at home every night. So they reverse the cycle. In the past, we teach you something here, and we send you back and do homework. And when you do homework, you do have difficulty, you have to wait until the next day to ask the teacher. In Hong Kong today, they do it the other way. We produce all the video through teachers' effort called the Hong Kong Academies, Digital Academy. The students watch the video unit in Chinese, English, math, and then they come back to class with all the time doing exercise. Remember, I'm helping you to transition into things like this. And that's why I say, now make sure you watch the videos and then we can do exercise. But I promise you, if I do it immediately, I will have a lot of complaint. Okay? Because most of the students will not watch the same thing at home. All right? They prefer to watch it in class and do homework at home. Okay? Step by step, I can assure you, all the videos are helping you to learn step by step. Okay? So you have to learn by picking up the details. Do not just clean on one very important misconception you need to unlearn. That is, you can always learn something, all right? You are here to become your own teacher. And we are here to help you to close the gap. Because after the first two learning contract, you need to come up with a proposal of your own, okay? By writing a proposal is not calculation, it's your thinking that is important, okay? We will do exercise in class, we'll do it immediately, okay? So having said that, I invite you, if you have not read this article, read it. It's an excellent article, it takes you just 10 minutes time. Where can you get it? Week number 5's public online discussion forum. And after reading this article, watch this very interesting presentations by Salman Khan, okay? It's a wonderful presentation of just 20 minutes, okay? He is the kind of guy, after he had produced his video, someone offered him 1,000 million US dollars to buy his tutorial. But he said, no, I produced this video for the sake of those who cannot afford to pay. Okay? So he made this open open up this free of charge to the whole world. And then Bill Gates, the CEO of Microsoft company, appreciated so much because exactly his video helped Bill Gates' daughter learn math. And then Bill Gates said, let me donate money to you so that you will have a team to help you to make sure your platform can help the whole world to learn. And because of this Salman Khan, you and I can make the best use of video to learn. And here is how he is explaining to the whole world the use of video is to reinvent educations. So do not be ignorant. Make sure you understand the world is changing. Okay? So make sure you study this at home. Okay, now let's get back to the business of this week, week number 6, by going back to week number 5. Okay? We begin each week by looking into what we have learned last week. And the best way to do this is to go to the specific link, let's say after class link. All right? Week number 5, and the specific thing, the content you need to learn, always come from the content learning. If you want to know what you need to do after or before you learn something, go to the process learning. Remember, in the first submissions, we have actually 4 links for you to upload something. But 3 of those 4 links are not compulsory. But it's there to help you to manage your learning. All right? Only 1 link is to collect your suggested exercise. So let's go to content learning. As of last week, we got through lecture 1, 2, 3, and 4. Okay? And studying this week, we go to lecture 5, 6, 7. Okay, so before we go to lecture 5, 6, 7, let's go back first during class activity. Okay. Remember, this is where we were last week. We studied something called the product rules. We studied something called the quotient rule. Okay? And we also studied something called the chain rule. Remember, towards the end of last week, I invite you to go home to study the proof of the product rule and also the proof of the quotient rule, as well as the proof of the chain rule. If you have been studying this, following along, you should have already stepped into the links here and also the links there. Okay? Let me just go to the links here. The notes there. Okay, the notes over there. Every single piece of notes is already there. Okay? Now, only one student asked me these questions. I hope many more will ask me the question when you read the proof. This proof was done by Professor Miller last week when you watched the way he proved it. So many students got a little bit confused. What do you get confused? Now I give you some time to watch it, to read this a little bit, so that and then we'll come back to the points of confusions. Okay, if you don't do the notes taking, at least you need to study the notes provided. Okay, everything you're going to learn, it's already well recorded there. It's not just the video. At the end of each video, there is the notes. Okay, study the notes. Do you understand the proof? Okay, it's very important because the proof is done in first principle, using the concepts of slope. All right. So this is the formula. How do we start out proving it using first principle? Okay. What are the points here you discover that makes you a little bit confused? So let us take a look at it. Why is this formula true? Do you have any problem with this first? Okay? Do you have any problem with this first? The pi represents a derivative. Okay? And this is the substitutions of this given functions with the delta x. Okay? This is an unwieldy expression, means it's going to look like very complicated. But so far, let's deal with this chunk first. Okay? And from this to this, do you understand this? I want to make sure that everyone is on the same page, because some of the time, because the video is problem, sometimes you cannot follow all the steps. And that's the difficulty. Sometimes you think watching the video is not suitable for you. But have you watched the video by comparing with the notes? Now let's take a look at it, okay? Just a couple of minutes. Do you see any difficulty for you to understand this proof just by looking into the simplifications of this step? Okay? Do you understand the assignments here? Any difficulty so far? Do you understand why this could be written using the notations of delta U and delta V from first principle? The advantage of extra notes like this is I do not need to repeat writing this on the whiteboard. Let's go through it from top to the bottom, okay? I do not need to play magicians by reproducing things. Now, any difficulty to understand these expressions? Delta V. V at the point x plus delta x minus V at the point x will got me the delta V. U of x plus delta x minus U of x will get me delta U. Okay? And with this much and this much here, you see the differences here. Okay? When you see the differences here, because U of x plus delta x is equal to U of x plus delta U. Okay? Is it too quickly for you to jump from here to here? So if this works out for you, then what's next? It's a fractions with rational number. Common denominator, you multiply this 2, you multiply this with that, you multiply this with that, you got this one, and then this 2 can be cancelled. Let me enlarge a little bit more. Okay, so you can see much more clearly. This 2 will be gone, okay, with the remaining of this 2, because this minus that is 0. Okay, when you got this, you plug this whole thing up there with delta x approaches to 0. You can simplify it like this, okay? So once you can simplify it like this, from this chunk to the other chunk, you see the shift of the delta x, okay? And how do we define this? This is the average value, and when delta x approaches 0, it's an instantaneous value. Okay? So from that, when you plug in here, you got this. The derivative notations has delta x approaches c. So the concept is, do you understand the differences between the average and the instantaneous? And then the principles of this note. Okay, the definitions of the derivative. This goes from this, and then we come to finally this particular equations. Have you rewatched the video from modifying with this notes? It's directly here. It's very simple. Everything is given here. All right? So, what about the chain rule? Very quickly, towards the end of last lecture, I say that sometimes you have to understand this. And the chain rule when you look at this box, the answer is here. It's a compositions of functions. All right? The compositions of functions with f a dot g of x, f of g of x. Now, sometime when we come to the concept, I might ask you some very interesting questions during the midterm. How do we interpret this? Okay? And this. In this class, we are emphasizing a lot on the applications of maps. We're not as much interested in the individual step. You can always pick it up. All right? So, with this particular chain group, eventually, let's take a look at that. This limit concept. Why do we need limit? Without the use of limit, can we come to the derivative? Okay? Can we just use average? We're interested in instantaneous value, a specific value at a specific point in time. Okay? So you see all of these examples that we've gone through. So I hope you went through these notes. So what are we going to do today? Now let's go to the recitations, which is on week number 5. That's one thing good about this. It's, you see that every week I do not just give you the week material. I give you the material from day number 1. Now we've done this, we've done this, okay? We've done small piecewise functions. And so today, let's carry on with that. And last week, we've done this 2 as well as this 1. So let's do a product group to review something. Okay? Can you just try doing this at your table?
Welcome back to recitation.
Okay, sure.
In this segment, we're going to talk about the product rule. And what I want to do first is remind you the product rule for 2 functions, because we're going to use that to figure out the product rule for 3 functions. So throughout this segment, we are going to assume that u and v and w are all functions of x. So I'm going to drop the of x, just so it's a little easier to write. This notation should be familiar with things you saw in English. So for the 2 functions, let me remind you. If you have uv, the product, and you take its derivative, so prime will denote df. Then we can take the derivative of the first times the second function left alone, plus the derivative of the second function times the first left alone.
Okay.
So this should, again, be familiar from class. And now what we want to do is expand that to the product of 3 functions.
3 functions, okay.
And we're going to explicitly use this rule. So UVW prime is what we're going to look at. So we're just gonna take advantage of what we know to figure out what this expression will be, what this product of 3 functions when I take its derivative will be. So in order to do this easily, what we're going to do is treat v times w as a single function.
Right.
Okay, so v times w will be our second function that essentially takes the place of the v up here. Okay? So using the product rule for 2 functions, what I get when I take this derivative is I get u prime times vw plus I take the derivative of this second thing, which is vw prime, and then I leave the u alone. Okay? We're not quite done, but you can see now, again, if we compare to what's above, you take the derivative of the first function, you leave the second function alone. You take the derivative of the second function, you leave the first function alone. But now again, what do we do here? Well, we have a product rule for 2 functions, so let's use that. So I'll leave the first thing alone, u prime, oops, that does not look like it v w plus, now let's expand this. Take the derivative of the first function there, that's v prime. I leave the w alone, plus the derivative of the second function, that's w prime. I leave the v alone, and I keep the u there. Okay? I'm going to just expand and write it in a nice order so we can see sort of exactly what happens. So u prime v be w plus v prime u w plus w prime u v. So what you can see here is what happens. You take the derivative of the first function, you leave the second and third alone. Then you take the derivative of the second function, you leave the first and third alone. And you take the derivative of the third function, you leave the first and second alone. And you add up those three terms. I would imagine that at this point, you anticipate a pattern. So if I had a fourth function, if I did u times v times w times z, let's say, and I took that derivative with respect to x, you could probably anticipate you would have four terms when you added them up. And that fourth term would have to include a derivative of the fourth function. So from here, actually, you can probably tell me what the derivative of the product of n functions is. And you can check it using the same kind of rule. But what we're going to do at this point is we're going to just make sure we understand this. We're going to compute an example. So since we know we know derivatives of powers of x, and we know derivatives of the basic trig functions, we'll do a product rule using those functions. So let me take an example. So we'll say f of x equals x squared sine x cosine x. Okay? And I want you to find f prime of x.
That is easy.
Okay, I'm going to give you a moment to do it. You should probably pause the video here. Make sure you can do it.
Okay, try this, and let's try to see if you can apply this rule. The rule has already been given to you. It's a product rule between two specific functions, and let's do it step by step. This is what we learned last time, and also we need to practice it this time. Okay? The answers are as there. Remember, calculus is a very conventional mathematics method. It's not difficult. You need to go through the steps. Before we begin today's class, and I receive a question that is very meaningful. Now that you have a team, okay, you need to tell me your team compositions, which two pair you want to put together as a team, and when you have a team of 4 persons or up to 5 persons at a time, when you're given a set of exercise, how can you divide the efforts among your team member to discuss, to come up with the solutions, and to make sense of the learning? Now that is very important. Now that you work in a table, so I would say 2 to 3 minutes, do it by yourself, and then followed by 2 or 3 minute discussions with your team member on your table, and then check the answer. You have to learn a very powerful way to learn as a team, all right? In the past, everybody's eyes on the teacher. But in this class, we want to make sure your cluster of students is very powerful, all right? So, yes, I heard something called substitutions now. How can we substitute a specific variable with a specific function and simplify it? What is the derivative of x squared? What is the derivative of sine x? What is the derivative of cosine x? And then, what is the derivative of sine x, cosine x? Okay? And very much, there are a lot of possibility here. It depends on how you represent these functions. Some will say this is u, this is v. Some will say this is u, this is v. Some will say that this is v, this is u. Okay? It's just a matter of choice, depending on which way you want to go. Then you need to make use of the generals. Okay? So I think some of you got the answers already. Since we just have 75 minutes time, otherwise we'll just give you a chance to write the answers on the whiteboard. That would be also great. Anyone who would like to volunteer? The answer? Volunteer your answer? Yes. Stop, you did it. Okay, just take a look. Okay. So first principles, all right? That's good. A lot of you have actually forgotten the product rule and used your implicit differentiations to get something done. That's very good. When you ask me, I would just do it the implicit way too. Tell me, no? Just try a little bit. You have to do it systematically, step by step. Let me try this. See that? All right. Now, please check your answers now for those of you who completed.
And then you can restart the video when you want to check your answer. Okay, so we have a product rule for 3 functions. We have an example that I asked you to determine, and gave you a moment to do it. So now I will actually work out the example over here to the right. So I will determine f prime of x. Now what are our 3 functions? Well, we have x squared is the first, sine x is the second, cosine x is the third. So we'll have 3 terms. The first term has to have the derivative of the x squared. That's going to give me a 2x, and I leave the other 2 terms alone. So I have 2x sine x cosine x plus, I may want to just write these below. Okay, now in the next term I should take the derivative of the sine x and leave the x squared and the cosine x alone. Derivative of sine x is cosine x. So I'm actually going to write this underneath. So we'll have put the plus underneath also, so remember it's a sum. Plus, so the derivative of sine x is cosine x, and then we have a times x squared times another cosine x, the third function. Okay? And then the third term, I take the derivative of the third function, and I leave the first and second alone. The derivative of cosine x is negative sine x. So I actually have a negative sine x times x squared times the sine x here.
You see that? Just come in.
I can do some simplifying if I want, but maybe if I were trying to write this nicely for someone who was reading mathematics, I would put all of the polynomials in front and all of the coefficients in front. So to be very kind to someone, I might write it like this. And notice cosine x, cosine squared x, and then minus x squared sine squared x. And there are other ways I could rewrite this and using trig identities, but this is a sufficient answer at this point. So this is actually a good way to write the derivative of that function.
That's very good.
And this is where we'll stop.
Now let's try another example, the cosine group, okay? This is the product group. What about the cosine group? Help reinforce your ideas and to pick up the technique.
Welcome back to recitation. In this segment, I'm going to actually show, well, you're actually going to show the derivative of tangent x using the closure rule. So what I'd like you to do, I wanted to remind you of what the closure rule is. So u and v are functions of x. We want to take the derivative of u divided by v. I've written the formula that you were given in class for this, and I'm asking for you to take d dx of tangent x using the closure rule. And the hint I will give you is the reason we can obviously use the closure rule is because tangent x is equal to a quotient of 2 functions of x. It's sine x divided by cosine of x. So I'm going to give you a minute to work this out for yourself, and then when we come back, I will do it for you.
please try to plug in the answers. So what is the derivative of sine x? What is the derivative of cosine x? And try to use the formula given to plug in to get an answer. That is the easiest way. Many of us, as I can observe from those of you who are doing calculus, they did it in implicit way. And that's what we are going to today. All right? The difficulty of doing anything in class with the exercises, we have to assume you did the class lectures video at home. But sometimes, for those of you who did not, I need to make sure we also need to show the video in class. So we do not have all the time to do everything. So that is very important. We try to plug in the values. Okay? Normally, in the past, when we do examination, the teacher would not give us this. Okay? We cannot even bring the formula in. We need to demonstrate the technique used. Yes. It takes about 5 minutes to plug in when we give it the answer. And that's why it's very important you understand the proof. Once you got the proof straightened out, you come to the formula. You use them, all right? Yes, you did it already, right? This is what we call a simple substitutions problem. Okay? Let's see. You got it in, you got it done. Yes. Yes, the simplest way is to use the formula. But the question you need to ask yourself is, what if I was not given the formula? What rules can I use to develop the answers as comfortably as we could? That's the reason why we need today's lessons. I see many of you did it already, so let me give you the answer.
Okay, so we want to find the derivative of tangent x. So let me work on this side of the board. So I'm actually going to take d dx of sine x divided by cosine x. Okay, so in this case, sine x is u, cosine x is v. So using my quotient rule, I know that first I have to take the derivative of sine x. That's cosine x. And then I multiply it by the denominator, the v, which is cosine x. So my first term in the numerator is cosine squared x. Again, one cosine x comes from the derivative of sine x. One cosine x is the v. It's the cosine x in the denominator. Then I have to subtract v prime u. The derivative of cosine x is negative sine x. I'll actually just write that one down. And then I bring the u along for the ride. So I multiply by sine x here. And then I take v squared in the denominator from the formula. V again is cosine x. So I take cosine squared x in the denominator. Now this at this point is a little bit messy, but the nice thing is that we can use some trigonometric identities to simplify this. So let me first write out what it is a little more clearly. Minus a negative gives you a positive. And then here I get sine x times sine x. So I get sine squared x. And then I keep divided by cosine squared x. Now at this point, some of you might have divided by cosine squared x here and gotten 1, and divided by cosine squared x here and gotten tangent squared x. And then from there, you can simplify to another trigonometric function. I'm going to go straight a different way to show you what that actually also equals. So there, at this point, I want to stress there are sort of two ways you can get to the same place. But I'm going to use the fact that the numerator is a very nice trigonometric identity that we know. We know cosine squared x plus sine squared x always equals 1.
Right.
So this is quite lovely. The numerator simplifies to 1. The denominator stays cosine squared x. What is this function? 1 over cosine x is actually secant x. So if you need at this point to rewrite the whole thing like this, right, 1 squared is 1, and in the denominator we still get cosine squared x. This tells you that, that 1 over cosine squared x is actually just equal to secant squared x. So again, what I want to point out is we've now taken the derivative of tangent x, and we got that that's secant squared x. Now, using this quotient rule, you can do the same kind of thing with cotangent x, with cosecant x, with secant x. You can find all these derivatives of these trigonometric functions using the quotient rule. So if you want to know what the derivative of secant x is, you should take d dx of 1 divided by cosine x, use the quotient rule, or in fact the chain rule would work well there also to find that derivative. So we are building up the number of derivatives we can find using these different rules. So we'll stop there.
So one more practice, that is the chain rule, okay? Because last time we covered 3 different rules: the product rule, the quotient rule, and the chain rule. You should have watched the video related to of these 3 rules and studied the notes already. And now let's do a chain rules example.
Welcome back to recitation. In this video segment, we're going to look at the chain rule, and specifically we're going to answer a question that I've placed on the board. I want you to find 2 values for theta, so that d theta of the function cosine squared theta to the 4th equals 0. At this point, I should also point out a few things. 1, theta is a variable in this case, and if you haven't seen it before, frequently we use it when we're dealing with trigonometric functions. Theta often represents the variable that measures angle. So if you haven't seen theta before, this is what it looks like. That's how you say it. And I'm actually doing the same things we've done before. I'm taking the derivative with respect to the variable theta of a function of theta. The other thing I want to point out, which I think we know already, but just to be sure, is that this squared here, cosine squared theta to the 4th, means I'm taking cosine of theta to the 4th, and I'm actually squaring it. So with that knowledge, I would like us to use the chain rule to find 2 values for theta where this derivative is equal to 0. So I'll give you a moment to take a stab at finding the derivative, setting it equal to 0, and finding some values for theta that make this equation, the derivative equal 0, and we'll come back and work on it.
Can you try this? That's the chain rule. Yes. Make sure you have enough practice of those. Now this time, no formula is given. But you can always refer back to the formulas given as of last class when you have written the notes. The implicit differentiation rule comes handy now. I see that you are very excited when you come to this. Every time we learn a new concept, the second class will want you to practice this, at least one question, okay? But that would lengthen the discussions in the context of we need to make sure that each one of you need to watch the video first, or learn the basics first. In the past, when you read a textbook, they do not have the video with you, but now, when we learn something online with the internet, we not only have the textbook, we have the video as the textbook, we have the solutions, we have the practice questions and the videos. So everything is so handy. So do not say that you cannot make the best use of them. Make sure you can overcome some difficulty. The English part is not that complicated. Finish already. Let's take a look at it. Okay, so let's close. Yes, learned. Wow. Oh, don't worry much about the 0 first. After you've done the expressions, you set it to 0. Yes. It's good. Of course, you can simplify by assuming a specific variable. Now, u equal to theta 4, right? So you can get it done easily. because we can always make it simple for us when we come to the manipulations. And the principle of substitutions comes in handy. Okay? I got 3 students for this already. All right? Let's try. Remember, the minimum of those is the manipulations of symbol. Derivative of cosine x is equal to minus sine x. Now you have a square cosine x squared. Derivative cosine x squared. You can use the product rule first. Okay? So what's the product rule? Yes, I got another student done. Very good. Let's try it. It's okay if you get it wrong, don't worry. You have to learn from the response. Yes. Now, of course, when you got the expressions of the derivative of this, you try to set it to 0 and solve the equations for 2 values of theta so that the derivative of this is equal to 0. Well, if the derivative of this is equal to 0, does it mean the slope is equal to 0? It's horizontal, right? Very exciting. Make sure to make the best use of a team member on the table. Ask them, what can we do about this? What are the possible things that could go wrong? Make sure you look around and see if team member can help. Yes, very interesting. Now you get involved with the radian concept, the pi concept. Okay, because of the time limit, let's go for it.
Okay, so the first thing we obviously need to do is be able to take the derivative of this function on the left-hand side. And I should say it's a little more complicated than an example you saw in the lecture, because in the lecture you were given an example with just 2 functions. So I want to write it a little differently just to show very obviously what the 3 functions are we're proposing. So this function, I can rewrite it as cosine theta to the 4th. There we go. And then I square that whole thing. That's really what the function is.
Right.
Okay, so we can see what is the outermost function here. The outermost function is actually the quantity of something squared. So the outermost function is x squared. What's the next function in this composition? The next function in is the cosine function. And then the last function in is the function taking something, raising it to the 4th. So it's very important you understand sort of the composition, which is the outermost function, which is the innermost function, in order to do this chain rule. Now, as you saw in recitation, you were given the example, dy, you had y as a function of t, sorry, not in recitation, in the lecture, you were given y as a function of t or a function of x, and then you had to put one other variable in the middle. Here we're going to have a composition of 3 functions, so we need to have 2 other things sort of in the middle. So let's write this out first. The outermost function, we'll call the whole thing y. So y is equal to x squared is the outermost function. So then this whole thing is x now. So then we'll write x is equal to cosine of w.
Yes.
Okay? And then w is equal to theta to the 4th.
That is a
Okay.
very
Again,
important
this is what you saw before in the lecture. So you write the outermost function, and then that function is a function of cosine of another one, cosine of w, and w is a function of theta to the 4th. So if I put all these back together, I have theta to the 4th in here, and then I square that, and I come back to the function I wanted. Now, we know from the lecture what we need to do to find essentially dy d theta. That's what we're looking for. Okay, so dy d theta you'll see, you remember from the lecture, it should be dy dx times dx dw times dw d theta. Okay, so it's slightly more complicated than we saw before because there's one more term. Okay, so now let's work out what these are. Well, dy dx is fairly straightforward. Dy dx is just 2x. And then dx dw, well, what's the derivative of the cosine function? The derivative of cosine is negative sine, so this is times negative sine of w times, and what's dw d theta? So w is a function of theta to the fourth, so dw d theta is 4 theta to the third. Now, when you look at this, you should remember x we sort of inserted into the problem to make the problem easier, and w we inserted into the problem to make the problem easier for us to follow. So we don't want all these x's and w's, we want everything in terms of theta, right? But what is w? Well, w is theta to the fourth, so I can replace that by theta to the fourth. And what is x? X is cosine w, but w is theta to the fourth, so x is actually cosine of theta to the fourth. Okay? So I get 2 cosine of theta to the fourth times negative sine, w again is theta to the fourth, it's theta to the fourth, times 4 theta to the third. Let's make this nicer. I'll bring the coefficient and the theta to the third in front, and this minus sign in front. I get negative 8 theta to the third, cosine of theta to the fourth, sine of theta to the fourth. Okay, and then the problem asks to find where the derivative is equal to 0. Find 2 values. Now why did I ask you to find 2 values? Because one is very easy. If this thing is set equal to 0, one value should stand out right away for theta that makes this product 0, and that is theta equals 0. So theta equals 0 is our easiest answer. Okay. So if you didn't do that, then you wanted the more challenging stuff. You could have done the other things also. So what about cosine theta to the fourth? If we want a product of 3 things to be 0, then at least one of them has to be 0. So I could have set cosine theta to the fourth equal to 0. And for what values of an angle, I should just say, for what values of theta to the fourth is this going to be 0? Well, this means that theta to the fourth is equal to either maybe pi over 2, or you could add another pi. Okay, so we could say pi, well, let's just say that's one example. Theta to the fourth equals pi over 2 would work, right? Because cosine of pi over 2 is equal to 0. Okay? And so then we could have said theta is equal to pi over 2 to the 1/4. Okay? That's another example there. We could have also done, we could have added pi to this and gotten another answer, but I only asked for 2. So I guess that I'm allowed to stop there.
That's great. You got it? So the first thing is your strategies to break down the functions into different pieces. Make sure you come back to this page, which is the after class activity, end of the week activity, week number 5. Okay, you also have the next set of homework, which is due October the 25th. So your table, your members could actually work together. Now, first of all, may I invite you to tell me your team compositions in week number 6, okay? May you tell me in week number 6 by going to this Dr. Van's Q&A hotline before the end of this Friday, using the specific links there, okay? The links there could be the links of your name and also the links of the pair. Use the pairs link. Oh, what happened here? Yeah. Okay, use the pairs link and then tell me the team compositions by giving me 2 pairs. The Moodle environment is something wrong today, so it's not fast enough. But anyway, I'm going to send you a reminder so that it's easy for you to use the table there to tell me before the end of this Friday. Another thing that is very important for you to know is now that the answer is out, okay? The answer for the previous set of homework is out. It's time for you to discuss the answer with your team member. Now remember, those answers are just an answer. Sometimes I did not draw the graph when it's required, but you understand it. So make sure you study them by downloading the answer. Study the answer by comparing the work you did. You have the paper copy with you, and then ask why it's done this way. What's the reasons behind this? A lot of you have already asked me questions on some of the questions that is not being discussed in class. Now the intermediate value unit, we have not talked about this. Okay, so make sure you study them. Look at the Moodle environment. Okay, looks like it's being not well done here. Okay, so but anyway, I would like to take attendance for today, and then I'll let you go. Hopefully everything is fine now. If not, it's all right. Look at that, it does not work. That's why it's one properly. And sometimes the easiest way to get screw up without an environment is in the class I prepared two hands, the traditional way and a new way. Okay? So make sure you read this article. It's okay, you have to go to the next class, alright? The Moodle environment must seem to be working properly, it's still connected. Now, I'm going through the patterns of coming to class for at least 30 minutes during this exercise. In this class, I have spent 30 minutes per question. Next time, it's 10 minutes per exercise question, and I still retain 45 minutes for the class lecture. It's very important. All right? So I'll see you next week after the national holiday. All right? Have a wonderful national holiday weekend. Enjoy yourself. I have not eaten mooncakes yet. I'm going to start doing it tonight when I'm grading your work. All right? So thank you very much for coming back. Look at that. It's still not working. So there's nothing I can do with this one. Yes, actually, that it does not work. That's the problem with it. They say something. But it does not, it's going to take too long. Just go. It's all right. Just getting into it. It's like, and of course, if you're not urgent to leave for the other class, you're free to stay. All right? Look at that. Even though tomorrow is it's not a holiday, you should be working. Okay, let me stop the video first. Okay, it's up to you to go. That's it for today's MATH113, Section 7. Until next week, see you.